This is the second part of the assignment for April 27th in Intermediate Algebra, 11.2 through 12.5, Part B, second assignment over those. 12.1, 15 and 16, Composite Functions. Number 15, f of x equals x squared plus 1, and g of x equals 5x. You're going to find two composite functions. What you do to find this first one is take 5x and put it in for the x over here. On the second one, you take x squared plus 1 and put it in for the x over here and simplify, like we do on number 16. F of x is x minus 3 and g of x is x squared. So f composite of g of x is f of g of x, and then g of x is x squared, so we can put x squared in there, and then f of x squared means x squared replaces the x up here. So x squared minus 3 is our composite function for f composite g of x. In other words, on the first one, f composite of g, we take the g, whatever it is, and replace the x over here, or x's. The second one, g composite of f of x, we take whatever the f of x is, x minus 3, and put it in for the x over here. So it's x minus 3 squared. And then I used FOIL, x squared minus 6x plus 9. Then 12.2, we're finding a way to see if graphs are one-to-one. One-to-one, well, the first thing we've got to have is a function. And a function is a graph that no vertical line will pass through it more than once. Like here. This here, no vertical line will go through it more than once. That means there's no x's repeating. Same way here on this horizontal line. No x's repeating. A vertical line would not cross it. So everything we have is already a function, meaning no x's repeat. We're asked, are they one-to-one? That means not only are the x's do not repeat, but the y's do not repeat. So I drew horizontal lines, or examples of horizontal lines. Any horizontal line, if it crosses our given graph in more than one place, which it doesn't on 15, it does not cross it more than once, so it's one-to-one, meaning no y's repeated themselves. Number 16, though, a horizontal line will lay right on top of the horizontal line that's our graph. So that means it's repeating all kinds of y coordinates. So it's not one-to-one. Number 17, we've got a V-shaped graph. Notice a horizontal line crosses it more than once. So it's not one-to-one. Notice this one over here, kind of a W shape. It crosses it more than once. So it's not one-to-one. Notice number 19, this graph here. Our horizontal lines only cross it once, so it is one-to-one. This in here, our horizontal line crosses it twice, not one-to-one. 21, our horizontal line crosses it quite a few times, not one-to-one. This one is one-to-one because it only crosses it once. Then we're given an equation, and we're going to start writing it. It's a function to begin with. We're going to write the inverse of it, and that's what this symbolism is here. First step, put y in for f of x. Just put y instead of f of x. Then step 2, switch x and y around. Instead of y equals x minus 5, it's now x equals y minus 5. Just switch them around. Step 3, solve for that y. Solve for that y. So I add 5 to both sides. X plus 5 equals my y, and that's my inverse. Number 25 and 26, the same thing. Here's my given function. I put y in for the f of x, like this. Then I switch x and y around, switch them around. Then it's going to take me a couple steps to get that y by itself. First, I subtract 9, x minus 9 equals 4y. Then I divide by 4. X minus 9 over 4 is my y. That's my inverse. 28. First I put y in, equal to negative 1/2 x plus 2. Then I switch x and y around. X equals negative 1/2 y plus 2. Then I do the work to get my y by itself. The first thing I did was multiply by negative 2. Negative 2x, and then negative 2 times this gives me plus y equals y. Negative 2 times 2 is negative 4. Then I get that y by itself by adding 4 to each side. So negative 2x plus 4 is my inverse. Then we skip over 12.3 and 12.4. We go to 12.5 where we're going to write things. We've got the given exponential thing here. 2 to the 4th equals 16 on number 17. Number 18 is 5 cubed equals 125. That is the same thing as the log to the base 5 from right here of 125 equals the exponent. Log statements always equal the exponent. Number 20, 10 to the 4th equals 10,000. So it's log to the base 10 of the 10,000 equals 4. And since it's 10, we could have wrote it just log of 10,000 equals 4, because base 10 can be understood. It's a common one. Pi to the 5th equals y. So log to the base pi of the y equals the exponent, 5. Number 24, 10 to the negative 2nd equals 1 over 100. So log to the base 10 of 1 over 100 equals negative 2. 26, 3 to the negative 4th equals 1 over 81. So it's log to the base 3 of 1 over 81 equals negative 4. And then 28, 4 to the 1/3 power equals the cube root of 4. So log to the base 4 of the cube root of 4 equals 1/3. Changing from exponential to logs. Now we're going to start using the things we've learned on this lesson to solve a couple equations here. 29 log to the base 2 of 8. What's it equal to? We don't know. That's for you to find out, and here's how you do it. Log to the base 7 of 49. Okay, I made it log to the base 7 of 49 equals x, because I'm looking for this out here. That means 7 to the x power equals 49 then. Going back to exponential form. Then 7 to the x, kept that side the same. I'm trying to get the 49 to have the same base as the left side did, 7. Well, 7 squared can be put in for 49. Therefore, x equals 2. What I was missing there was a 2. Number 32, log to the base 2 of 1 over 32. So log to the base 2 of 1 over 32 equals x. So that means 2 to the x power equals 1 over 32. And so 2 to the x, okay, I'm trying to get this 32 over here with the same base over here if I can. 2 over here is my base, so I start working with 32. 2 times itself 5 times is 32, so 2 to the 5th equals 32, but that's in the denominator, so I move it up to the numerator. 2 to the negative 5th equals 2 to the x, so therefore my x is negative 5.